All right. Hello and welcome to the Future Directions for Visual Basic talk. I'd like to welcome you all here. It's great to see so many VB people in the house, especially at the PDC. Yeah, woo! All right, let's say yeah. Make sure at the end of the talk we've got a big stack of the I'm a VB things for your badge holder. So by all means find me or Lucian or Lisa. We'll be around with them. Show your VB love here at the PDC. So let me introduce myself for a moment. My name is Paul Vick. I'm a principal architect at Microsoft. And for the last 8 years, I've primarily been the author of the language specification for Visual Basic and the sort of the shepherd for the language design process. And today I'm going to be co-presenting, and I'm hoping I get his last name right, Lucian Wischik. And he nodded, so I guess that's right. Lucian's been with the team for quite a few years now, and he's actually going to be taking on many of the responsibilities that I've been carrying, primarily owning the language specification and also helping to guide the language design process. So the way we're going to do this talk is I'm going to talk for a little bit about, sort of set things up a bit. Lucian's going to come up and give you a good long tour through what we're doing in the next version of Visual Basic. And then I'm going to come back on and talk a bit about some of the future trends beyond the next version of Visual Basic. All right, so when we start to talk about where Visual Basic is headed, I just wanted to take a moment to kind of go back and talk a bit about where it's been. And primarily what the purpose of Visual Basic is at Microsoft. So if you look at what role Visual Basic has played at Microsoft, it's largely been the way that we've made the Microsoft platforms accessible and easy to use for all Microsoft programmers. So starting, of course, way back 17 years ago, which is hard to believe now, 17 years ago with Visual Basic 1 and to Visual Basic 3, we really made Windows programming accessible in a way that really had not been achieved up until that point. And Visual Basic played a key role in making Windows the premier application platform in the world. Now, after Visual Basic 3, we move on to the next set, Visual Basic 4 through Visual Basic 6. And what Visual Basic 4 through 6 did was took component programming, COM and OLE automation and ActiveX, and made that actually programmable by human beings. I don't know if there are many of you who actually had to do COM programming in C++. Here, raise your hands here. Okay, I'm sorry. I feel sorry for you. I had to do some of that myself. And it was vastly easier, of course, in Visual Basic. So then the next three versions, which is where I sort of entered the picture with the Visual Basic 7, which was the first .NET version of the language, we brought that same power and simplicity and straightforwardness to the .NET platform and helped establish the CLR as the premier managed runtime in the world as well. Hopefully none of you are Java, believers here, because I think, we've really played a really important role in moving that into the centerpiece of the Microsoft programming platform. So as we start to look at Visual Basic 10 and beyond, as we move into the double digits, which is just a phenomenal achievement for a language, what we're looking to Visual Basic for is the same things that we've looked to it for the previous 9 versions. And that is to take the Microsoft platforms and Microsoft platform initiatives and make them accessible, easy to use, and to reduce the amount of time and effort that programmers have to expend to be able to work with Microsoft technologies. And this is our mission. This has been our mission for the past 17 years, and I expect it to be our mission for the next 17 years going forward and into the infinite future when we're programming Visual Basic by simply thinking Visual Basic thoughts. And of course, it'll be a lot better when we're having to think our programming because we don't have to think semicolon and curly brace all over the place. All right, so now it's really impossible to talk about the future of Visual Basic without talking about our sort of fraternal twin language for the past several versions. That is C#, of course. Now, those of you who went to Anders' Future of C# talk, you saw a very similar slide. And I wanted to take a minute to talk about what coevolution means for Visual Basic. And we've kind of had this history of sort of going back and forth between cooperation and rivalry between the two languages over the past 7 or 8 to 10 years, since C# came on the scene, I guess, in about 8 years ago. Now, on the cooperation side, there's been an incredible amount of knowledge and technology transfer between the two teams. Right? If you look at what C# really brought to the table in its first version, one of the great things about C# was that it introduced a lot of the concepts that VB pioneered into the C-style languages. So you had first-class enumerations, first-class properties, first-class events, all things that first showed up in Visual Basic on the Microsoft platform, and then were adopted into the C# language. And similarly, if you went to the C# 4.0 talk yesterday, and which will be repeated tomorrow, you saw, again, a transfer of ideas that have been pioneered on the Microsoft platform in Visual Basic. So ideas such as dynamic binding, optional parameters, named arguments, these are all things that VB users have been using for years, and now our C# brethren get to sort of join us with it. So now the transfer has gone both ways, too. I mean, if you look at Visual Basic 8.0, where we introduced overloaded operators, unsigned types, we introduced the generics, which were pioneered on the C# language first. And if you look at the last version, Visual Basic 9.0, the link concept was really a pioneer cooperation between the VB and the C# team. So we have this great history of cooperation between the languages. But we also have a somewhat checkered past of a sort of a sibling rivalry between the two languages. And what that's meant then is that one language will get something that the other one won't, and then those users will grumble, and then the next version, the other language catch up. We kind of go back and forth. And in particular, for VB users, there have been frustrations like the introduction of nullable types in C# 2.0 that didn't appear until Visual Basic 9.0, or in C# 3.0, the introduction of automatic properties, which Lucian's going to demonstrate today in Visual Basic 10.0. And so what we've heard loud and clear from our customers, from the Visual Basic programmers, from the C# programmers, is that it's very frustrating when one language has a capability that the other doesn't. And so what we're making is a promise as we go forward to be very conscious about how we plan the languages and ensuring that no matter which language you choose, you're not going to feel a sense of regret when you look at what the other language has. So as Visual Basic users, this means that you're guaranteed in an even stronger way, that as capabilities appear on the .NET platform and as new ideas appear in the C# language, they will also appear in the Visual Basic language. Now, we're going to take a big step towards that vision in Visual Basic 10. There still are going to be some things that it may take a release or two to fully catch up on. But this is the direction that we're heading. This is the commitment that we're making to Visual Basic users. That you can have confidence in your language and that you don't have to worry about capabilities appearing in other languages. And similarly, for the C# users, we make the same guarantee. Okay. So now what I'd like to do is I'd like to hand the presentation over to Lucian. And what we're going to do is walk through a lot of the features that you'll be seeing in the next version of Visual Basic. So, pass
Thank you,
off
Paul.
Lucian.
I'm really excited that so many people have turned up. It's a real honor to be able to demonstrate Visual Basic 2010 to you. I'm really excited about this version of the language, and I'm going to go straight into it. Here I just started with quite a simple program. It has an array of integers. I'm going to create a separate thread and print out those integers onto the console. So we're going to create a new threading.thread object. We're going to pass it the address of some thread function that we're going to have to call. And let me just populate that thread function now. It creates the thread with the thread function. It passes this array of integers, and then it executes the thread, and that will go through each of the scores and print it. And let's just run it. Okay, there's nothing special there. But what's irritating about this is that you've had to break up your code. You've had to put the body that executes in the separate thread into a separate piece of your source code. You've had to pollute your class or your module with additional top-level functions that make it more awkward for other people to read and see what's going on. So we got rid of that. Let's take this body that used to be in here. We'll put the sub straight inside the function. That means we can delete this sub. It's no longer needed. We no longer need to pass scores into the thread. And the great thing about doing this is that the variable scores here is local to the function. We've put the code where it belongs, straight inside the function. That means the compiler knows the variable scores. It knows what type it is. We don't need to cast it to an IEnumerable. And if we hover over the variable O, we see that the compiler has inferred that it's an integer. This is really great. I've been using these non-stop since they were introduced. We call it multi-line lambdas. We can do them with function lambdas as well as sub-lambdas. Here I'll write a simple one. Here's a simple function. It takes in I as an integer, and it returns either this guy or this other guy. And you look at this, and you say, well, what is the return type of this function lambda that we've created? The compiler's figured it out. It's figured out that it returned a double. Although, if you wanted, you can declare the return type explicitly. Okay, those are the statement lambdas. I'm going to show you a neat place where we can use them. Watch this. So in this case, I just spawned an entirely separate thread to print them all. Let's do it more fine-grained than that. Scores.asParallel. I'm sorry. For all element in the scores as parallel, we're going to print it out to the console. I'm going to run this code straight away and see what it does. 60, 70, 80, 90, 100, 10, 20, 30. Okay, so it really did do them in parallel. That's phenomenally easy, right? I've never written concurrent code that was as easy to handle as this, and our new feature of sub-lambdas is what's made it possible from VB. We're using P-Link, the new parallel framework extensions. You might have been to talks on this already. There are a few more tomorrow. I think you also saw something else here about parallelism. Yeah, it's great. We can take advantage of multi-core really easily. We can also misuse it really easily. There are some things which just should not be done in parallel without careful safeguarding. Probably sending output to the console is one of them if you expect the order to be the same. So yeah, it's quite a powerful gun, and maybe you have to think about using it more carefully. Like something like this, scores2 equals again, using as parallel in a link query. This is a link query which has got no side effects, therefore it's a perfect candidate for automatic parallelization. And with as parallel, we can do that. That's all I'm going to say about concurrency. I'll get on with the rest of the talk. Actually, no, it's not. Before I joined Microsoft, I was an academic. I spent 10 years in universities working on concurrency theory. And you know, every single time someone stood up on stage to give a talk about concurrency, yeah, they drew some nice primitives, but it's never that nice. Every single person in the audience is looking at it thinking, I don't like it. That's irritating. That's irritating. Here, I think with Link, what the Link team has done is they've given us the ability to leverage multi-cores in a way that we haven't seen before anywhere. Really, really easy. And I expect this is going to be a really important future. Let's go on with somewhere else that's going to be an important future. Interop with dynamic languages. I'll take out my Python interop snippet. Dynamic language runtime interop. Let's walk through this code. dim Python equals create runtime. I'm creating a new instance of the Python runtime engine. The next line says set search paths. I'm telling it where to find the standard Python libraries that I'm going to use. The next line is key. Python.useFile. What that's going to do is it's going to load random.py. It's just a standard library in the Python library. Load it as a module. And what happens, what the DLR implements, 9 Python implements for this, is that the random module object corresponds to that module of Python. All of the shared members of the random all of the members of the random module object are the top-level functions that were defined in random.py. And so we can invoke it. We can use a Python shuffle on the scores array. Let's just print it out. And run it. It has at the moment a 1 second startup time for the DLR. We're working on that. Okay, 100, 30, 20, 10, 90. It shuffled them good. Now, I don't want you to think that the entire theme of my talk will be screwing up with the order of arrays of integers. Why are we doing this? Python's a really awesome language. I mean, I love VB, but I've been doing a lot of Python programming over a while. And where I've used it in 2 places was one, it's got a giant array of really good libraries. I mean, we use .NET libraries all the time. And now with what we've put into VB and C#, we can use all of the Python libraries as well, and all of the DLR libraries as well. The other reason where it's great is I'm a bit of a games player. I remember playing Civilization 4 a lot. The way they architected that was the game, it was written in C++, and they put all of the scripting in Python. The idea behind this was that players and users of the game can script it very easily. That's what we're giving you here with the DLR interop. We're giving you the capability to add other language scripting to your applications. Actually, there's something about this that we can improve. We called set search paths with a new string array, and we passed it 2 strings. It's kind of redundant. I mean, the compiler can look at this, and it can figure out that it's a string array. So we implemented that. You no longer have to declare the type of arrays. Let's go up here. It's going to get better. delete this one. The compiler says dim scores as integer. Okay, it's an array of integers. Let's try and trick it. 12.0. Okay, so this array has got integers and doubles. What's it going to infer? Answer, double, because all of these things can be converted to double. Okay, let's try something even more nasty. Hello. What do you reckon it's going to do here? Warning, cannot infer an element type because more than one type is possible. Object assumed. Yeah, as you said, object. But the other thing we're doing is we're being really scrupulous that when the compiler does infer object, it never does it without warning you, because that can mess things up. If it infers object, then you lose IntelliSense, and we really wanted you to be aware of where that's happening. Let's try some other neat things with the arrays. Dim matrix equals. I've made a 2x2 identity matrix, or a jagged array. Actually, that's not quite a jagged array. Do you know what it's done here? It said array initializer is missing 3 elements. It thought I was creating a matrix, and it warned me that my matrix wasn't correct. The way I make jagged arrays is delimit the separate arguments, and if I hover over this, dim jagged brackets, parentheses, parentheses, it's a jagged array. It might seem stupid. I was surprised by the applause there when we had inference for arrays. It might seem stupid, but I think it taps into something really useful. I mean, the point of this is that you spend every single hour of your working life coding in this language. You don't want to be fighting it. You want it to be easy. We're trying to simplify it, simplify the bits that really don't deserve extra work. And the case we saw where it was actually handy was when we called set search paths, and we passed a small array. That's a common pattern. We've helped with that. Let's get rid of this. I mean, arrays are all very well, but the fact is that a lot of the time we're going to be using real data structures, list or collection or whatever. Dim scores as new list of integer. Okay, another common pattern. You create the thing and then you have to call add on it just to populate it. We looked at that and thought we can do better than that. What the from keyword does is it's the exact equivalent of calling add on each of the elements in turn. So it's going to call add of 53, add of 99, add of 40. And if I run this now, 53, 99, 40. It's got the duplicate ones because I forgot to delete them. Okay, that's good. Actually, we can do more than this. Dim scores as new dictionary. We've created a new dictionary here. I'm going to run this. Bart 53, Lisa 99, Homer 40. Okay, it created the dictionary. Again, the way it did this is the from keyword is exactly equivalent to calling add on each of the elements. A dictionary has a method called add, which takes a string and an integer. So it called add of Bart, 53, add of Lisa, 99, add of Homer, 40. We created a new dictionary. I think this is a bit of a case of Python envy. Those of you who have done Python know that dictionaries are just the basic data structure that you use all of the time. You want it to be really easy to use. We've made it kind of a bit easier to use here in Visual Basic. Well, there are dictionaries, but let's try to do something with our own. data classes. Dim scores as new list of student. Student is a class I defined over here. Student is a class which inherits from business object. It has one property called score, which is an integer. It has the backing field for score, and it has the boilerplate code to implement that property. And you look at this and you think, boilerplate code, it was a pain to write, it's a pain to read. Why do we have to write it all of the time? And the answer is, we don't. Auto-implement property, thank you. Auto-implemented properties, if you don't declare a getter and a setter yourself, then it automatically populates them for you. Let's go down here to business object, which is also the same. Business object was a bad name. Student isn't a business object. A student is a person. I should call it that next time. Sorry, I get lost in the data world where everyone talks about business objects. Okay, let's delete this boilerplate code. Could I save questions till the end, please? Thank you. Why are we doing this? I mean, the theme here is simplify, simplify, simplify. The more code you have to write, the harder it is for people to read, the harder it is for them to maintain. The statement, the multi-line statement lambdas that we saw at the beginning, I think they were a really good case of this, where writing the extra function print scores meant there was even additional sub that people had to read to understand your code. We moved it right inside where it belonged. Here with the auto properties, we're only writing stuff that the maintainers of your code need to read. There isn't a piece of code here that they don't need to read to understand what you intended or what you've implemented. Okay, let's get back to it. Collection initializers. I made this list of students, and now I want to add to it. What I'm doing here is I'm using object initializers to create the new student. Actually, that's kind of a bit messy. Let's do this a bit more smartly with extension methods. I don't know how many of you have been using extension methods. We've been using them all of the time. I love extension methods. Just to recap, we defined this thing as an extension method. Its first argument is a list of student, and the effect there is that if someone calls scores.add, where scores is a list of student, and they supply the right arguments to their add function invoke, then it will end up calling this guy instead. And that means that we can simplify this down to just scores.add with the arguments, and when we call this add function, it ends up invoking the extension method. And you're looking at this thinking, wait a minute, he can do better than that with the from keyword. And yeah, that's right. Now let's run that. Great, it worked. We've got an easy way of initializing a data structure. These guys, don't you just hate them? Delete. 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 Implicit line continuation characters. There's one here. delete. I don't know, I mean, the applause speaks for itself, but it's not all fun and games. There are going to be lots of unemployed underscore characters out there now. Yes. I want you to spare a thought for them. We've set up a website, www.unemployed_com. Go there, see if you can donate, see if we can reskill them, retrain them as parentheses or XML literals. I think there'll be something good for them. Actually, I'm really glad that you reacted positively to this, because on the development team, removing these line continuation characters was a really major work item for us. I mean, the problem is that what the compiler has to do now is, if you've got one statement and another statement after it, it has to figure out, what if, did they really mean to write two separate statements, or is it possible that both of these things together are part of a single valid statement? This problem actually is theoretically undecidable, according to computer science. In general, for arbitrary language grammars, in Visual Basic, we just had one particular grammar to work with. And really, it took an enormous amount of work to identify all possible cases of ambiguity that might arise from removing this underscore character and nail them. You can't remove them in every single place. There are still places where underscore characters are needed. These are generally the cases that would be ambiguous if you didn't have them. So that's the background to that. Let's move on. We can do a lot better than just printing to the console. I wrote this function, business objects to HTML. Bobs to HTML, it takes a list of business objects and it emits an HTML literal. The HTML literal it emits is just going to be a regular HTML table, and then I've got a link query in here. For each business object in the list, where it's got a valid identifier, let image equals bob.name with JPEG stuck to the end of it. I prepared for this by assembling a few JPEGs in the same directory as the program. And then it creates a table row inside here. Actually, delete, delete, delete. Okay, and let's turn this into it. Dim HTML equals bobs to HTML of scores. Console.writeLine of HTML. There's an error here. I know that it's an error that at least half of you have run into, because we get questions and complaints about this a heck of a lot on the forums. What does the error say? List of student cannot be converted to list of business object. Yep, you've all run into it and you've all hated it. It says something new here, actually. List of student cannot be converted to list of business object. And you're thinking, damn it, it can, because students inherit from business object. It says, consider using IEnumerable of business object instead. Okay, we'll do what it says. The error goes away. I'll run it. And it's worked. It's created the HTML element. I want to talk about what it's doing here. The feature is called generic co- and contravariance. Anders demoed it in C#. What we've said is that, well, you can't convert a list of student to a list of business object, because that wouldn't be type safe. Someone could put in a different type of business object, and that would corrupt your list. But IEnumerable is read-only. That means no one can corrupt your list. That means it's type safe. And the key enabling technology for this actually hasn't been implemented yet. What happened was that IEnumerable in the BCL has been made generic. It said IEnumerable of t now takes a purely output generic parameter, IEnumerable of out t, and that out keyword is what they use that will allow this scenario and what you use to allow this scenario for your own collections, your own structures. It's complicated, you know. I still don't get my head around precisely all of the ways, and when someone shows me a piece of code and says, why isn't this working? It takes me half an hour to figure it out. That's why for Visual Basic we spent so much effort on those error message. Consider using IEnumerable instead of list. What the compiler is going to do is it's going to point out the places where variants can help you, and it's going to help you. It's going to say, use this, make your class use support variants in the other way, so that users of your class can pull the same trick. We've got HTML. We can do a lot better than just writing to the console. Word interop. Ha! Optional and name parameters. Those of you who went to the C# talk will have seen them being very pleased with optional and named parameters. And you'll be thinking, wait, didn't VB have that all along? Yes, we did. But that's not what I want to talk about here. Let's just run this program, see what it does. It took the HTML table that I made, it pasted it into Word. Remember that I created the names for the JPEG images, I saved them in the directory. Close. Dim Word as new Microsoft.interop.word.application. So that was relying on the primary interop assembly we had. I added a reference to it, add a new Word document, and then copy the HTML to the clipboard and paste it into Word. There's a problem with this, you know. I'm going to show it to you through Reflector. Here's the application I just made. I'm sorry, the typeface is kind of small. I haven't figured out how to enlarge it. We'll go into the references, and there we have it. This great big reference to the primary interop assembly, Microsoft.office.interop.word.dll. And you have to deploy this DLL to your customers, or make sure through some means that every time you deploy your application, you've also deployed this interop assembly to it. And it's a big thing. I mean, it's a real pain to deploy. So we implemented this feature called no peer. Let's see how we exercise that. Microsoft.office.interop.word. This is the reference I had to it. Properties, embed interop types, set to true. Let's rebuild the solution. And run Reflector. There it is. No more reference to the primary interop assembly. You're thinking, where's it gone? Well, here it is. We embedded it straight inside your executable. And now you're thinking, wait, damn it, it's megabytes big. Have you just mushroomed my executable? No. We only embedded those types and those members of those types that you actually use in your code. Look at this. Document, selection, visible. So it's adding a negligible amount to your code here. That's all I have to talk about. I'm sorry, Paul, I ran over. I want to say, I'm new to this job. I'm really honored to have this opportunity. I'm really grateful that Paul remains on as VB Architect Emeritus. I'm really keen to listen to you guys, to hear what are your pain points, what are your suggestions. I'd really like it if you come find me. I'll be in the lounge in the hands-on lab. Speak to me, tell me what you want, and I'll see what we can do. I'm going to hand back straight over to Paul, and we'll leave questions until the end. Thank you.
All right. right. So, thank you to Lucian for that wonderful demo of what you'll be seeing in the next version of Visual Basic. And so now I want to take a few minutes. Let's see, actually we're doing well on time. Take a few minutes to talk about some of the trends that we see going on beyond the current version and the next version of Visual Basic. So now what I'm going to talk about is not Visual Basic 11. It's not necessarily Visual Basic 12 or 13. It's really trends that we think will shape the next 5 years, 10 years, 15 years of the language. And nothing I'm going to talk about is tied to a particular version of the language at this point. So as we think about where programming languages are going, how many of you went to the Future of C# talk? Okay. So if you went to that talk, Anders talked about sort of 3 large trends that he sees and that we as a unified sort of visual languages at Microsoft, the 3 trends that we sort of see going forward. And what I want to talk about is how we see those trends affecting the Visual Basic language. So now the first trend that we want to talk about is dynamicism. Now, the interesting thing, of course, is that this isn't so much a trend that is going to just affect the future, but of course has been a part of our past for a very long time. But the value of dynamicism, it's not just that you get to simplify your code. I mean, that's great, that's wonderful, that's kind of what we talk about sometimes when we talk about the value of dynamic languages. We talk about how you can delete the types and it'll figure out what you need. And that's all really well and good. But I picked this picture because the real value as we move forward for dynamic language features is in working in a world where coupling between the layers of your application become even looser. So now in the past, you may have been writing multi-tier applications, with a client tier, a middle tier, a database tier, and you may have controlled every single one of those tiers, or you at least knew the guy who controlled the other tiers, or the guys. You usually found out when there were going to be changes. But as we move into a world where more and more applications are tying together very disparate sources of data, we're tying together information from the web, from the mesh, from the kind of things that you see in the Azure services. I hope I got that pronunciation right. I can't tell. But as you tie together more and more of these data sources, many of which you don't control and you may not actually know a lot about, the loose coupling that you get from dynamic language features becomes even more important. Like on my desktop, I use the Twitter microblogging service. And about every month or 1 month or so, my client breaks for a couple, 6, 7, 8 hours because the Twitter folks change their APIs or they change their data format, and my client doesn't handle that, and so I have to wait for an updated client to show up on my desktop to go back to resume to using that service. And what the promise of dynamic language features are going forward is that we can loosen the coupling between applications and the data and the services that they integrate into the language. And so what we see going forward, certainly the dynamic language runtime offers us a great opportunity to start to build these kind of libraries where you don't have to rely as so much on the specific structure of the data, the specific structure of the APIs. And as we look forward, we see these types of language features only growing in importance, so that it may not just be dynamic method binding, dynamic conversions, but it may be fully instantiated dynamic types where you don't really know anything about them or you know very little about them, but you can simply make a minimal set of assumptions about the APIs and the data that you're using. And so we believe that the dynamic language features in VB really position us well as we move into this more loosely coupled world of programming. So that's the first trend that we see for programming languages, and we believe that the dynamic language features will only strengthen over time. We'll create, ironically, I'm talking about loose coupling. Over time, we'll create a stronger coupling between the VB language and the dynamic language runtime as its capabilities grow. So the second trend that we talk about, and Lucian touched on it a bit in his part of the presentation, is concurrency. Now again, most of the time when you go to talks about concurrency, what everybody wants to talk about is your desktop and about how we're not able to create CPUs that go faster, and so we're getting more cores. And that is certainly an important aspect of programming as we move forward. But concurrency also has a lot to do with what you're hearing here about distributed applications. It's not just being able to more efficiently use all the CPUs on your desk, but it's also, as applications become distributed across multiple tiers, as you start to move some of your logic into services on the web, as you start to run some of your applications in the browser, the being able to slice up your application and have it run concurrently, coordinated across multiple CPUs and multiple tiers, is going to become even more important. And this is really a problem that Visual Basic is uniquely designed to tackle, because as human beings generally, we're pretty much single-threaded. We can only handle about one thing at a time. Although, when I was giving this in a dry run, one of the feedback I got said, well, I'm not really so sure. This was a male person giving feedback. He said, I'm not so sure. It may just be males who are single-threaded, because my wife certainly can do multiple threads. So I don't want to, cast aspersions on any of those of you who can really carry on multiple things at one time. But the point is that as we think about concurrency, we have decades of research on how to do concurrency, and we've got all kinds of different ways of doing it. We've got the parallel frameworks, which we're releasing, and that has a lot of really nice things. But we haven't yet found that simple paradigm for how you take an application and split it up across multiple tiers and across multiple CPUs. So Lucian was certainly correct when he said that the P-Link idea certainly raises the level of abstraction on concurrency. But we think there are many, many more levels that we'll need to raise it before it becomes really, truly useful. And so the role that Visual Basic has to play with this is to do what it's always done, which is to bring the very complex concepts and make them simple. And so we're going to be spending a lot of time and a lot of effort figuring out how to make your applications run in a more concurrent and distributed world. And so now the final trend I want to talk about, I want to spend more time talking about than the previous two, because I think, if anything, it's probably the most important trend that we have. And in fact, more than I think any other language on the .NET platform today, and it's one that we've actually already started down the path of really taking advantage of. So the great thing about declarative programming is I used a train map here, because it's not about building the tracks or figuring out where the trains are going to run. It's about having the map and say, I want to go from here to here, and just having somebody else take care of it for you. And if you look at what Visual Basic has already done, we've already started down this path. I think one of the most significant features for Visual Basic 9 was XML literals. LINQ was great. It's a wonderful feature, but XML literals is something that's consistently come up in feedback as very valuable. And the thing is, XML literals, it's just a trick. There's this great LINQ to XML API set that any .NET language can use to construct XML objects. You can construct an XElement object, XDocument, whatever you want. And all we did was we gave you a nice, simple, straightforward, declarative syntax for working with this API. And all it does is a very, very simple translation from the XML literal format to the API calls underneath. And yet, just this simple little thing, people find incredibly useful and powerful. And why is that? It's because you get to just say what you want, not how to actually create the objects. And furthermore, you get to say it in a format that looks like what you want to get. It's how you see it in your head. You don't have to do the abstract mapping from XML format in your head to this is how I'm going to do the APIs. And so we see this really as a model for how the Visual Basic language moves forward and how it continues to bring simplicity to the Visual Basic and to the .NET and to the Windows and to the Microsoft programmer. So now the challenge, though, with that is that the XML literal feature was only doable because we had three or four guys working at Microsoft in the team. They had access to our source code. They could make changes. They checked it in. They went through all the rigmarole that we require you to go through to get things into the Visual Basic source code. And it's really not a particularly scalable way of approaching adding declarative things to the language, right? We can only do maybe one or two of those, if we're lucky, per release. And only the highest value are we going to be able to do. Because, of course, we're trying to address the full range of millions of Visual Basic users. Whereas you may have a library that's tailored to what you're writing your application for or your domain. And what you'd like to do is take that library and put a nice syntax, nice declarative syntax on top of it, just like we did with XML literals. And so what we see is, as a future direction for the Visual Basic language, is moving in a direction where you would be able to do the kind of things that we did with XML literals, so that you can write libraries that surface as declarative syntax, so that users of your APIs, users of your libraries, don't have to do the abstract mapping from whatever domain that you're working with them in into the API calls. You can go ahead and do that for them. So now the interesting part of this is that the challenge then becomes not so much a language challenge, although there is some challenge in figuring out how syntaxes can mesh. I mean, I will add that there was an enormous amount of work in figuring out how to make XML fit nicely into the VB syntax. So clearly there is language work there, but there's also a lot of compiler and framework work to be done. And so what you saw a little bit of in the C# talk is what we're also working on, which I would call sort of opening up the box. That if you look at how the Visual Basic compiler works today, it is this giant black box that sits in the middle of your development process. And in one end goes text, and out the other end, assuming you don't have any errors, you get an assembly. And that's all you got. And if you look at a lot of the tools that are produced, they go through an enormous amount of effort to deal with the fact that there's this big black box that no one has any visibility or very little visibility into. So, you have .NET Reflector that looks at the assembly and tries to reconstruct what your program was so that you can analyze it. And what we need to do is move towards a place where that box is opened up, where you can actually see the pieces inside the compiler, when you can see the parser, the semantic analyzer, the code generator, and that you can then start participating in the compilation process, so that you can then have a way to surface your libraries into the syntax of the language itself. Now again, I wanted to emphasize what I said earlier. This is really a multi-version vision. I don't think in VB11 we'll get there. I don't know in VB12 maybe. That would be great. VB13 at some point. But we're starting down this path today. And what we have is a parallel effort to what you saw at the C# talk of moving the Visual Basic compiler into managed code so that those services that we have inside the black box today can be made available to you as Visual Basic programmers. And then down the road, you can start participating in the compilation process and add your own declarative syntax to the language. And in the short term, this is also great for tool developers, those of you who are tool developers, because even before we get to a point where you can do something like XML literals, we'll be able to start taking advantage of the services that we have inside the compiler. So there are God knows how many VB and C# parsers out there in the real world, because of course every time you want to write a tool that works with VB or C# code, you have to write the parser, and you take the specification and you try to turn that into code, and you probably get it wrong, and it doesn't work exactly like the VB compiler because we get things wrong. And so what we'd like to do, at least in the nearer term, is move towards a place where those services are available to you as developers. So if you want to work with code, if you want to execute code, if you want to do the kind of REPL that you saw with the C# compiler, those sort of services will be available to you in nearer term than the point where we can reach where you can actually start to influence the syntax of the language. And in fact, I expect probably pretty soon we're very near the point where we can show very similar kind of things that you saw in the C# talk. And in a couple of slides, I'll have a pointer to the various blogs. Watch there. I think we should, as soon as we can do that, we're going to have it up and you can see it in action. It's actually really very exciting. We did some of the prototype work already. If you went to some of the workflow foro talks, we've done some early prototyping of that work to work with workflow. All right, so I want to go now kind of close up the talk here. Say, I hope you've gotten some ideas about where we're headed with Visual Basic. That yet again, Visual Basic is really the place we look to take the concepts that we put on the Microsoft platforms and make them easy, approachable, and powerful for all of Microsoft's developers. So it's really wonderful that we've gotten to this point where we're now entering the double digits for the language, which is a major milestone for any programming language. And I think we have an exciting roadmap sort of laid out for the next 10 versions. And when I'm old and gray and we're doing Visual Basic 20 or Visual Basic 30, it'll be great. I hope I'm still coming to the PDC. And we'll be seeing what they're doing then. So I wanted to thank you all for coming to the talk. Now what we've got is I want to just talk for a moment about some of the additional resources. If you missed the Future of C# talk, if you're a C# developer, they're going to be repeating that tomorrow, so keep an eye out for it. Jim Hagunen did a dynamic languages talk that I don't know if it's going to be repeated, but certainly has been recorded and be on the web. That if you want to learn more about dynamic languages and how the dynamic language runtime works, I'd really encourage you to look at his talk. There was also a lunch talk today talking about natural interop. I had to shorten it because it's like 5 lines long. There'd be nothing else fitting on this slide. That talks a lot about how the dynamic interop works between languages and between languages and COM. And tomorrow there'll be a panel, an interesting panel on the future of programming languages that's going to have Anders and a number of industry people on it. Should be very interesting discussion to hear what they have to say about their vision for where programming languages are headed. If you want to follow on Visual Basic, the Visual Basic Developer Center is a great place to go, run by our own Beth Massey, sitting in the back. Woo, Beth, all right. Yeah, let's have a round of applause for Beth. She does amazing work. And then I listed several of the team blogs up here. So the VB team blog, Lucian now has a blog. I've got a blog. Actually, Beth has one. I didn't have space. Sorry, Beth. But if you go to any of those, there'll be pointers to the other, and there are lots of places to get more of a day-to-day kind of feel for Visual Basic, your daily dose, your daily fix. All right, so actually we're doing very well. We're on time, so that means we have some time for Q&A. If you have a question, if you come up, there's a mic right here in the middle. If you come up and ask the question, and then Lucian and I can answer the question. And I wanted to thank you for coming, and please fill out evaluations. That lets us know how we're doing, what you liked and didn't like. And now we're open for questions.
What are your thoughts on iterators?
Yes, I'm glad that was the first question, because that is, I think, the one major area where we have not achieved parity with C#. It is a very important feature. More libraries are starting to take advantage of them, being able to easily define iterators. We would very much like to have that in the 10.0 release. It's looking very unlikely that will happen, although we can all think good thoughts. But I would expect to see it as soon as we possibly can get it in. It is a little bit of work, but we do see it as an important thing to add to the language. So thanks for your question.
Is there any thought being given to shortcutting dependency properties?
Yes, I think that, so the question, so shortcutting dependency properties like in WPF and, yeah.
Like you're doing with properties now.
Right. Well, and that's kind of where, that's the interesting thing about some of the declarative ideas that we've been pursuing is that, again, like this is sort of, there's lots of places like dependency properties and I guess, routed events and WPF as well, where it'd be nice to add an abstraction layer on top of it because you have to do all this boilerplate code. I'd say that right now there are no plans to add a higher level sort of syntax or simplification, but it is something that we get a lot of requests for, and it's something we're thinking kind of actively about because it's definitely becoming a more dominant thing as WPF's popularity increases. So I wouldn't bet against something appearing in the future. So thanks.
We saw that it is possible to use objects from dynamic languages, but when will we be able to use Visual Basic as a dynamic language?
You mean in terms of what kind of features?
When will we be able to have again something like VBScript?
Oh, so you mean in terms of making it easy to be able to create objects that are scriptable, create dynamic objects, sort of like ones that appear in Python or Ruby?
When we'll be able to write a VB program with Notepad and then save it and execute with on-demand, on-the-fly compilation.
Okay, I understand. Yeah, I think that hopefully, so not in the next version, but as we move towards having the compiler become more of a service, one of the things we're looking at is building scripting-like services around that, because it basically those kind of scripting services become more available. Something that looks a lot more like, say, what VBScript used to, or VBA. Those are definitely things that we're very interested in doing. And so I would expect that not in the VS 2010 timeframe, but at some point beyond that, that is a very high priority for something we're looking at. Because VB does have a very traditional roots in scripting, and we think that that's a very important thing that a lot of people do. So yeah, so thanks.
With VB10, are we able to do late-bound calls out without having option strict off for the whole file?
No. So for VB10, we will be retaining the same approach to warnings and errors around option strict that we've had, about late binding that we've had. You can turn that. You can through the project properties just turn the error off for late binding if you wanted to use that. but we will not have an equivalent to sort of a dynamic keyword that would just switch it off. It is something we're considering for the future, but I don't think in VB10 you'll see that. So.
Okay.
All right. Anybody else? All right. Thank you all for coming. It was very great to be able to talk to you guys about it.